Okay, this should look familiar, this differential equation. Okay, this is the same differential equation that we just did. The unknown is r, and r is a function of t. This time we're going to use the method variation of parameters. And I want you to be able to see that using variation of parameters or using integrating factors, using either of those methods leads you to the same solution. Okay, so again, we're going to start off with, now let me say this by side, as a side note. Variation of parameters, here's the key way to remember it. Y equals u, y1. Okay, so we're going to do that step 1, step 2, step 3. Step 1, find y1, which is a solution to the complementary equation. Step 2, find u, and we've got a differential equation, and we're going to integrate to find u. And then step 3, multiply them together to get y. Okay, but in order to do that, first thing we need to do is to put our given differential equation in general format. So let's see here. So general format will be r prime plus 1 over t natural log of t, r equals e to the t over natural log of t. Okay, so now our step 1 is find a solution to the complementary equation. Okay, so our complementary equation is r prime plus 1 over t natural log of t r equals 0. Okay, r prime equals negative 1 over t natural log of t r. This is separable, so this equation is separable. It is a separable first order linear equation. So we're just going to separate those variables, and we're going to love it. R prime over r equals negative 1 over t natural log of t. For some reason, separation of variables I enjoy doing that method. You know, I really like it. It makes a lot of sense to me. All right, so let's rewrite this. We'll have dr 1 over r dr equals negative 1 over t natural log of t dt. And we're going to integrate both sides. Now this left-hand side is going to be equal to the natural log of r, and the right-hand side is negative natural log of t plus a constant. So how did I do that so quickly? Well, I actually kind of did it on the other video. So for this side right here, for this equation, right, I just did that on the other video, so that's why I remember it. This equation, right, I've just got that memorized. Okay, now, looks like if natural log of r is equal to the integral of 1 over r dr, and this integral is equal to this, and this is equal to this, must be that the natural log of r is equal to negative natural log of t plus a constant. Now, we are trying to find just a solution, right? We're just trying to find a solution to the complementary equation, not the general solution. So I can let c equal 0. I could let c equal 1, it doesn't matter, but here I'm just going to let c equal 0. It'll disappear. So we'll have natural log of r equals negative natural log of t. Okay, and now I need to solve for r, so I'm going to raise both sides or exponentiate both sides. So e let me just actually just copy this and start on a new page. Copy, paste. Okay, so e to the natural log of r is equal to e to the negative natural log of t. Okay, this left hand side again is going to equal r. That's easy, that's what I wanted. The right hand side, I'm going to rewrite it as e to the natural log of t to the power of negative 1. So I'm going to take this negative and bring it to be my exponent. So I'm using my log rules, right? Log rules. So we have negative natural log of a is equal to the natural log of a to the negative 1. Okay. And why did I do that? Because I want my e and my natural log to cancel each other out. So I'll have natural log of t to the negative 1 over natural log of t. So I'm going to choose R1 to be 1 over natural log of t. All right. So I did step 1. Step 1, which is to find a solution to the complementary equation. I did that. I use R1 equals 1 over natural log of t. Now I need to find u. So step 2. Compute u. I always think it's funny when I write find u or find t, because it's not like it's lost, you know. It's like, go find that. It's not lost. Okay. I like compute better. So let me try to get more sophisticated with my speech. Okay, how are we going to compute u? Well, we know the formula for u. Formula for u is that, remember, u prime equals q over y1. That's what we're kind of remembering. Okay, that's me. And I'm smiling. Okay, so now how do I apply that in this situation? Well, we'll have u prime is equal to, what is my q? Let me go back. Remember, use the q from your general format, right? So you want to use the q from the general format, e to the t over natural log of t. If you use this as your q, you're going to get the wrong answer, because q is based off of your p and q are assuming that your equation are in the general format. Okay, so for q, we're going to use e to the t over natural log of t. So e to the t over natural log of t is q, and then that is divided by y1. But what is our y1? Our y1 is r1. Copy, paste. Okay. So I can simplify this. I'm just going to multiply. Do you see? I'm just going to multiply the top and the bottom by a natural log of t.
It's 9:15.
And I'm just going to get e to the t. So u prime is equal to e to the t. I can integrate both sides to get u, right? So the integral of the integral of du equals the integral of e to the t dt. So u is equal to e to the t plus a constant. So u is going to be, I need a general solution of this differential equation, right? I need a general solution. So u is a general solution, so I have plus c. The y1 is a particular solution. I do not have plus c there. So I figured out my u. So we said u is equal to e to the t plus c. And we've got r1, we've got u, and now we've got step 3, which is the easy part. Step 3, which is going to be to compute r. And the formula we use is, well, before we had y equals u, y1. But for us, now our unknown is r. So I just have r equals u, r1. Now what was my u? U is e to the t plus c. E to the t plus c. And what is my r1? R1 is 1 over natural log of t. So r equals e to the t plus c over natural log of t. And let's go back and see if that is the solution. Yes, it is. That's exactly the solution that we got using the method of integrating factors. So I don't know which one you would say is easier, which one you're more comfortable with, but all the time both methods work. So it's good to know both approaches because the more tools in your tool belt.